Section 5.5 is titled Solving Equations by Graphing. The steps for solving equations by graphing are listed below. I would pause this video right now and get them written down. I will explain each step as I go. Alright, let's just jump into some examples here. Solve by graphing. Number 1/2 x minus 3 is equal to 2x. Now, normally we'd want to just use algebra here, get our x's to one side, maybe do some dividing or multiplying, and solve from there. But this section wants you to think about doing or solving this equation in a little bit different way, or a little bit different of a manner. So, step number 1 says use each side of the equation to write a system of equations. Okay, so here's one side of the equation. That's going to give us y equals 1/2 x minus 3. The other side of the equation gives us our other equation for our system, y equals 2x. Okay, so there's step 1. Use each side of the equation to write a system of equations. Step number 2 says I need to graph the system. So let me bring in some graph paper here, and we will draw the graph here. I'm going to move the directions or the steps out of the way, and let me draw a coordinate plane here. Extend that just a little bit farther. Okay, we need to graph each equation. I'm going to start with the blue line here, 1/2 x minus 3. So it's in slope-intercept form. So I'm going to start at the y-intercept of -3. My slope is positive 1/2, so that means up 1 and right 2 to get to there. Up 1, right 2, up 1, right 2. Instead of going up and to the right, of course we could go down and to the left. Down 1, left 2, down 1, left 2, down 1, left 2, and that's probably enough points. And if we want, we could draw the line through it. Go ahead and do the second equation. Y equals 2x. Start at your y-intercept. There isn't one there. That's like plus 0. So we make a mark at 0, and we use our slope of positive 2, or 2 over 1. So up to right 1, up to right 1, up to right 1, but I'm not getting any closer to the blue line. I'm probably going to need to go down 2 and left 1. Down 2, left 1. What I find is I've got that common point, or that point of intersection, probably going to be right there. Let me draw in my red line. There it is. And the coordinates of this point here looks like the x value would be -2, the y value 1, 2, 3, -4. Okay, so I have a potential candidate at -2, -4. If we go back to step 3, it says find the x value of the intersection. That point is the solution. Well, what we need to do then, we need to go and check and see if -2 works in our original equation. So we're going to plug -2 in there and in there. Okay, so let's try that. So we got 1/2 times -2 minus 3. We're going to see if that's equal to 2 times -2. We're going to put a little question mark because we're not sure if it's equal yet. 1/2 times -2, half of -2 is -1, minus 3 equals 2 times -2 is -4. -1 minus 3 is -4, so -4 equals -4, which means our solution is -2. X equals -2. That is our answer. Let's try another one here. I'm just going to leave the graph paper up because we're going to need it here in a second. Number 2, 2x minus 1 is equal to -1/2. That's a -1/2 x plus 4. Okay, solving equations by graphing sometimes is pretty helpful if we have different numbers in front of x. Maybe we don't have a nice whole number, like here we have -1/2. Maybe it was -2/3 or -5/8, or something that doesn't give us a great number, that doesn't easily jive with the other x on the other side. Okay, so graphing is a nice alternative when we don't have the greatest of coefficients or numbers in front of x. Okay, so step 1, we need to make the system y equals 2x minus 1, and y equals -1/2 x plus 4. And then we need to go and graph it. Whoa, that's not even close. Let's try that again. That's not bad. Okay, so we got our coordinate plane. Go ahead and graph each line. Start with the blue line, 2x minus 1, start at negative 1, and then your slope is 2, so up 2, right 1, up 2, right 1, up 2, right 1, up 2, right 1. Again, just trying to get as close as I can, down 2, left 1, down 2, left 1, and we can draw our line supposed to be through those points. Go ahead and do the same thing for the red line. Y-intercept of 4, so 1, 2, 3, 4 is right there. Slope of negative 1/2, so down 1, right 2. I've already got an overlap there. Down 1, right 2. I'm not going to go any farther because I'm probably pretty sure I've got my overlap already, so we'll just draw that in there. That overlap appears to be the point. So let's see, x value is positive 2, y value is positive 3. What we're really concerned with is the x value of 2. Okay, so we need to go back and plug it into the original equation. We're going to put it there, and we're going to put it there. Okay, so 2 times my x value, which we think is going to be 2, minus 1. We're going to see what negative 1/2 times your x value of 2 plus 4 is equal to. 2 times 2 is 4, 4 minus 1, negative 1/2. So half of 2 is 1, but it's negative, so negative 1 plus 4. Let's see if I can't make that a better 4. I think I just made it worse, so let's try again. 4, there it is. 4 minus 1 is 3. Negative 1 plus 4, same thing as 4 minus 1 is 3. That works out, so our answer then is 2. We can also use solving equations by graphing with not just linear systems, but we could also use absolute value, or use graphing to solve absolute value equations. So number 3, let's go with the absolute value of x plus 1 is equal to the absolute value of 2x minus 4. Okay, if you remember way back in chapter 1, this is section 1.4. If you don't remember, you can pause the video, go back and take a look. But when we were solving absolute value equations, remember that there were 2 different equations that needed to be solved. 2 different, I'm just going to call them EQNs. EQN is short for equation. 2 different equations. The first equation was what I called normal, where you just drop the brackets. X plus 1 equals 2x minus 4. The second equation was flipped, or add the negative. Add a negative. That's an E, negative. Okay, so then it was x plus 1 for the left side. The right side was negative, and then 2x. Sorry, not plus 4. Let me get rid of that. 2x minus 4. Okay, so if we go back to, I'm going to have to use a different color other than red. So for the first, the normal equation, so we got y equals x plus 1, and we also have y equals 2x minus 4. Okay, on the one on the right hand side, the second equation, we'll have y equals x plus 1, and we will have y equals, now I'm going to distribute this negative sign, so negative 2x positive 4. Negative 1 times 2x is negative 2x. Negative 1 times negative 4 gives me positive 4. Okay, so I'm going to have 2 equations to be solving here. I'm going to actually have 4 lines to graph, but I'm going to do them on 2 separate graphs. Okay, so extend that just a little bit. Alright, so for the first equation, x plus 1, start with your 1. For your y-intercept, up 1, right 1, 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 and so on. Instead of up and right, could go down and to the left. And we can, whoa, sorry, my hand slipped there. We can draw our line. Okay, do the same thing with the yellow one. Start at your y-intercept of negative 4, 1, 2, 3, 4, that's here. And a slope of 2 means up to right 1, up to right 1, up to right 1. We're getting closer. Up to right 1, up to right 1. Now I think we finally found our spot right there. Okay, that point appears to be the point 5, and then I believe it's 6. Yes, 5, 6. Okay, so we'll keep that point in mind, and we'll come back to it here in just a second. For the second set of equations, the second system, we're going to need a graph again. Going to graph our two lines. We already know what x plus 1 looks like. It's the same thing as the other blue one. Okay, get those drawn there. And draw the line through them. Close enough. Do the same thing with the yellow one, but we got a little bit different. The slope, or sorry, the y-intercept is positive 4, so 1, 2, 3, 4 is up here, positive 4, and our slope then is negative 2, so that's down to right 1. And I've already got my intersection point, so I'm just going to make one more point, and then I will draw my line or sketch it in. This point right here looks to be the point 1, 2. Okay, but remember, we're not really interested in the y values. We're really what we're interested in is the x values. Okay, so I'm going to go back and plug. We'll go back and work with the left one again. We're back over here with the 5. We're going to plug the 5 in for that x and for that x. Actually, we'll put them there and there in the original red equation. Okay, so it was x plus 1 equals 2x minus 4. Okay, and we're plugging in 5 for each x value. So we got 5 plus 1, 2 times 5 minus 4. 5 plus 1 is 6. 2 times 5 is 10 minus 4. And 10 minus 4 is 6. So that does work. So x equals 5 is one of our answers. Now we need to do the same thing with the second equation. We're going to plug this x value of 1 in for that x and for that x. Or if you wanted to substitute this on the right hand side, you certainly can. And that's what I'm going to do. I'm going to make this x plus 1 equals negative 2x plus 4. And then my x values are going to be 1s. So I'll have 1 plus 1 equals negative 2 times 1 plus 4. 1 plus 1 is 2. Negative 2 times 1 is negative 2 plus 4. If I owe $2 and I give somebody 4, my change is 2. So this does work as well. So your other answer, x equals 1. Alright, last one. You guys, I want you to try this one on your own. Pause the video after I get it drawn. Do your work, and then you can kind of compare as I do this once you restart it and hit play. Number 4. So the absolute value of 2x plus 2 is equal to the absolute value of x minus 2. Alright, go ahead, pause it, try it. When you're done, go ahead, hit play. If you get stuck, go ahead and hit play, and but challenge yourself. Try to do this one without the help of the video. Alright, so the first equation, remember with absolute value equations, we need to set right two different equations. Okay, the first one is normal, so we'll have 2x plus 2 is equal to x minus 2. The second equation, 2x plus 2 is equal to negative, and then x minus 2 again. Okay, and then you can split it into two separate equations. Y equals 2x plus 2 and y equals x minus 2. Do the same thing on the right hand side. Y equals 2x plus 2 and y equals, again, distribute a negative 1 here, negative x plus 2. And then we can go ahead and graph these two systems. Okay, we'll start with 2x plus 2, that's here. For your y-intercept of 2, up to right 1. For your slope, up to right 1. Hopefully that gives us enough room. And then we go down to left 1, down to left 1, down to left 1. We'll go one more, down to left 1, because we do have that room there. And if we wanted, we could go even farther. Whoops, maybe not. Maybe if I slide the graph just a little farther, and then we can draw our line through it. Okay? Go ahead and do the same thing with the yellow one. Y equals x minus 2, so we start down here at negative 2, and then our slope is positive 1. It'll be 1x. So up 1, right 1, up 1, right 1, up 1, right 1, but we're not really getting any closer to the blue line, so we probably need to go the other direction. Down 1, left 1, down 1, left 1, down 1, left 1, still not there, but now we're there if we go one more space. So this point right here looks to be negative 4. Let's see, 1, 2, 3, 4, 5. That looks like -6, -4, -6. We'll come back and verify that here shortly. Okay, we'll do the same thing with the other system. Start with the blue line, y equals 2x plus 2. Actually, I'm going to redo the y-axis here. See if I can't make that a little better. That looks better. Clean that up. 2x plus 2 with the blue one. So we're up here at 2. Slope of 2, so up 2, right 1, up 2, right 1, down 2, left 1, down 2, left 1, and we'll go one more, down 2, left 1. Hopefully that will be enough. And there's our blue line again. The second line, the yellow one, -x plus 2, my y-intercept is +2. So I've already found my y-intercept, or sorry, not my y-intercept, my intersection point. I'll graph the other two, a couple other points, so the slope is -1, so down 1, right 1, or up 1, left 1, draw my line, but I already have my intersection point. It's on the y-axis, so my x value is 0. Where it crosses the y-axis is 2, so 0, 2. Now we need to go back and verify. Okay, I'm going to keep using green here. With the left equation, now we're back to this one over here. That's an arrow. 2x plus 2 equals x minus 2. Okay, and we're going to use this x value of 4. We're going to put it right there. We're also going to put it right there in that x, and we're going to see if we get the same thing on both sides. 2 times my x is -4 minus plus 2. I'm not worried about the y value at that point. And then -4 minus 2. 2 times -4 is -8 plus 2. -4 minus 2 is -6. -8 plus 2 is -6. -6 equals -6. That one works out. So x equals -4 is one answer. Now we need to do the same thing for the second equation. We still had 2x plus 2. The right side was a little different. I'm going to use this, -x plus 2. And we're going to use the x value of 0. Okay, so 2 times 0 plus 2 equals opposite of 0 plus 2. The opposite of 0 is still 0, so 0 plus 2 there. 2 times 0 is 0 plus 2. 0 plus 2 equals 0 plus 2. We got the same thing. 2 equals 2, and it works. So then my x value is 0.